Our next speaker is Associate Professor Nick Diakopoulos from Northwestern University, who is here to talk about neural network technology, which is advancing in its ability to synthesize new content. So what are the implications of this for journalism? So, Nick.
Thank you. Thank you for the introduction, and thank you for having me here today. I'm always happy to get a promotion in my introduction. I'm actually an assistant professor still at Northwestern University in the School of Communication. So I'm going to tell you a little bit about some initial work I've been doing looking at sort of the capabilities of neural networks in the context of synthesizing and creating new media and new content. So let's start this off here. So in Hollywood, it's typical to circulate a high-quality headshot of a photo of yourself when you're looking for work as an actor or actress. So here are two of these headshot images of up-and-coming actors in Hollywood, in Los Angeles. So what if I told you that one of these photos is fake? One of these photos is of a person that doesn't exist. Which photo do you think is the fake? Let's see hands for the woman up here. Who thinks the woman is fake? Okay. And who thinks the man is fake? I would say a few more of you think the woman is fake than the man is fake, but actually I was lying to you, sorry, they're actually both fake. These photos are the output of a research project from NVIDIA, which is a graphics chip maker. And what they've done is they've managed to synthesize these images of faces, these high quality sort of celebrity-looking images. And they've synthesized these by training a neural network model on huge corpora of these photos that learns what faces look like and is then able to generate them. So they can generate any number of these faces, and in fact, you're seeing sort of an array of the different generated faces that they've created. They can morph in between faces, and if you follow this YouTube link at the bottom, you'll go to a project page where you'll find an hour-long video that kind of creepily transitions between photos of these fake people. So imagine going to a party and just having this video, an hour-long video looping between images of fake people. So that's the kind of fancy stuff you can do with this technology. So what are neural networks? This is sort of the next generation of machine learning. The technology has actually been around for about 30 years in terms of the sort of core mathematics of how this works. But really what's changed in the recent past is kind of the availability of data and the ability to train these systems with very, very large data sets. And the way it works is, you have this idea of artificial neurons, and these neurons are learning patterns from these large volumes of data. Neural network technology has led to a drastic performance increase in things like speech recognition, computer vision. So these are tasks related to translating samples and signals from the world into symbols that can then be manipulated computationally. And of course, this isn't just for recognition types of problems, but as I showed you in my first slide there, they're also being used for synthesizing media. So just a brief primer on sort of how these neural networks work. Sometimes these are referred to as deep neural networks. So on the right-hand side, you can see you have multiple layers of these neurons. The neurons are the little dots. and you have an input layer at the bottom, and then you have a few middle layers, which are a little bit smaller, fewer neurons. And then at the top, you have an output layer, which is essentially making a final decision, a distinction in this case. So you could imagine inputting, this would be for a classification type of network, inputting an image and asking a question, is this a cat or dog? Each pixel in that image gets fed into a neuron in that input layer. Those subsequent middle layers are picking up on patterns and sets of signals from the lower level neurons. And then finally, those get synthesized up into the output layer. So that's kind of a brief conceptual idea of how these work. Now, of course, faces can be synthesized as we saw before, but they can also be manipulated in characteristic ways. So for instance, in this example, I'm showing you some synthesized faces that change the emotions in different ways. So on the left-hand side, you're seeing an input image, and then in the first column over, you're seeing the synthesized version of the angry face. In the middle column, you're seeing a synthesized happy face, and in the right column, you're seeing a synthesized frightened or fearful face. Oops, is that, no, sorry. I'm not sure that video is playing, unfortunately. But the image on the right would sort of animate and show you the transition. It's a video that shows you a transition between a neutral face and a smiling face. You know, we can not only change emotions in this way, we can also change demographics, things like skin color, age, gender. This next slide actually shows some of those variations, so you can see what the outputs look like there. On the left-hand side, you're seeing more female types of images that have been imagined. On the right-hand side, sorry, that's not, sorry, left to right is not female. Left to right is age, sorry. So on the left-hand side, you're seeing younger faces synthesized. On the right-hand side, you're seeing older faces synthesized. And then you're seeing a lot of variations in between with different hair color and rows with different gender characteristics and so on. These aren't the only characteristics, again, that you can change. You can open and close eyes. You can, you know, if you want to have an image with someone with a hipster beard, you can synthesize that, no problem. So facial hair, things like that. Another example is the ability to manipulate environmental conditions in synthesized imagery. So you can actually transfer the environmental conditions from one image to another. So on the left-hand side, you're seeing input images, and in the upper left, you're seeing the input image of a winter scene of a road. And on the right-hand side, you're seeing a synthesized or AI-generated image of a summer version of that road. So you can see the snow has been substituted with vegetation. And in the lower left, you're seeing an input sunny image, and on the right, the AI-generated rainy image. So you can imagine that, you know, when we can manipulate what the environmental conditions look like in an image, this can then complicate things like verification of images on social media. You know, sometimes journalists will get corroboration for an image, for instance, by looking at the weather report from where that image is purported to be taken from. So when you can kind of change those weather conditions, this could kind of make that job more difficult. Video synthesis is also on the table here. We saw a brief example of this in Astrid's opening talk. Hopefully, I'm not sure why these...
Especially our friends who are lesbian, gay, bisexual, or transgender. I visited with the families of many of the victims on Thursday, and one thing I told them is that they're not...
So it's a little choppy, but maybe you get the feel for it. So what this is actually showing you is a synthesized image, synthesized video, rather, that is using audio that has already been recorded or that already exists. So Obama actually said the words that he said in that video, but the neural network is learning how to map that raw audio signal and those raw audio features into mouth shapes that it can then composite onto a 3D pose of the figure in the target video. So the left-hand side is the input video, and the right-hand side is the synthesized video. So you can imagine essentially taking someone's words and putting it on a different video of the same person saying those things. So obviously lots of sort of capabilities or issues that might come up with that, but the technology is kind of rapidly advancing to be able to do these types of lip syncing and video retargeting types of applications. We saw this example in Astrid's opening presentation, the video puppeteering idea. This is a project called Face to Face, where they're kind of demonstrating this, this video puppeting. Oh, here we go, here's the video. So more examples of Trump's face kind of mimicking the input actor's face there. You can imagine the sort of the mouths of information propagandists really watering when they see this type of capability, right? You can imagine putting out fake videos of politicians saying or mimicking certain actions or reactions. The same type of neural network technology is also capable of synthesizing voices and audio. So you can actually go to lyrebird.ai. You can upload only 1 minute of your voice, and then type in another sentence, and it will synthesize you saying that sentence in your voice. So you can imagine that being used in conjunction with the first video of Obama, where I could train Lyrebird on Obama's voice, type in a sentence of him saying something that he actually never said. I get that synthesized audio, and then I use that synthesized audio to retarget a video of Obama saying something that he never actually said. Major companies are also working on this technology. Adobe has a project called Voco. It's more interactive editing, so don't forget Adobe makes all kinds of media tools, Photoshop and so on. So they're interested in how to use some of these advanced techniques interactively for authors of media to be able to edit audio files. They've done some human evaluations with these synthesized voices, and they've actually found that subjects mistook the automated sentences for real ones about 60% of the time. So that doesn't really bode well for our own ability to be able to recognize when these are not authentic statements or audio recordings. The same technology can also be used for text synthesis. This is actually, oh, sorry, not getting the reference there. This paper is called Automated Crowd Turfing Attacks and Defenses in Online Review Systems. And what they've managed to do here is apply the same technology to generate Yelp reviews, right? So you can control a knob and define the tone or the rating of a review and generate completely fake restaurant reviews for whatever restaurant you want. They also have a knob that controls the repetition or novelty of review, so they have different axes of kind of control over the type of information that's being synthesized here. And you can kind of see two of the example reviews that they synthesized. You can imagine those parameters also being repurposed for, say, political or propagandist dimensions. So, I might want to comment that's a little bit more negative on this policy position or a little bit more positive on this policy position. So what happens, when this type of technology is unleashed on public commenting periods, something that we do a lot in the US. Whenever there's a major policy, it's typically open for public comment. People can submit comments online. There have already been cases of being able to detect sort of automatically generated comments that have been injected in those processes. And I think this type of technology is going to make that even worse. I'll just add that they also did some human studies of the reviews that were generated here, and they found that human users rated the synthesized reviews just as useful as the real ones. So that's a little scary, right? If we can't perceive the difference between totally fabricated comment and a real one. So where are we heading? We're really kind of heading toward this version of machine-altered reality. Certainly photos have been manipulated for hundreds of years, right? Very soon after that technology was invented, people were splicing and dicing photos in different ways in order to represent visual reality in the way that they wanted to represent it. What's new here, I think, in terms of these automated techniques, these neural network techniques, is that they enable a whole new scale of generation of images, of videos, of voices, of text. All of the pieces of evidentiary evidence that we're used to building our notion of reality on top of. So they enable a whole new level of scale, pervasiveness, potential personalization. If you imagine combining some of the things that Paul was talking about in terms of learning what your interests are, you can imagine synthesizing a piece of media, a video or something like that that was specifically adapted to you or that was maximally meant to gain your trust, for instance. So I think this really challenges us in several ways. So it challenges authenticity and trust. We don't know whether or not the media that we'll encounter on social media or anywhere else on the internet for that matter, we don't know if it's authentic. We don't know if it's real. Is this actually a depiction of reality? Or has this been fabricated? Is this synthesized? Is this some imagination of a neural network that has looked at a lot of data from the world? So what happens when we can no longer trust media, a mediated version of reality? I think we're going to have to figure that one out. I think there's some responses, some pragmatic responses we can talk about. We can talk about developing forensics tools. These are potentially useful. So you can look at the pixel statistics of an image. You can look at the sensor noise in an image and know that it came from a certain camera. Sometimes you can look at compression artifacts. Sometimes you can look at geometric signals from an image, look at the lighting, for instance, and tell that it's been faked. So there are forensic techniques that could be applied and are being applied in some cases to determine if this image is an authentic, real image. But these are hard to apply. You need a high level of expertise, and actually, they're not often definitive. They can't always tell you that, yes, this image has definitely been doctored or this image is definitely fake. Still, I think there could be some value to investing in those tools to develop the core forensics algorithms as well as developing interfaces so that journalists, let's say, can use those forensic algorithms more effectively in kind of helping to verify the reality that they're perceiving online. We could also potentially talk about certification standards. How can the media perhaps develop standards that certify an image as a real image of reality at the point of capture, so that on my camera, cryptographically, I may be able to sign that image and verify with some third-party trusted service that this is actually an image, this is the image that it purports to be. This image was produced at this date and time by this camera. Funnily enough, Canon and Nikon actually did do this about 10 years ago. The encryption was hacked not too long after they launched the technology. But I think that just means that the implementation wasn't there. I think that if it were properly implemented, we could potentially start developing these standards and deploying these standards, potentially even bringing on hardware manufacturers like Apple and Google and so on to include this type of certification in smartphones. And then finally, I think we could talk about media literacy. So, this is not only for end users who would be encountering all sorts of media, including synthesized media online, but also for journalists who need to kind of be trained more in what are the particular signals that I might be able to pick up on that can tell me or give a clue that this could be sort of a piece of machine-altered reality. I think we're going to need to think a lot more about how we train people to cope with this environment. So one final thought I'll just add here is that if we can't trust our eyes when we see media, what can we trust? If we can't actually trust the output of some media system, what can we trust? And I would argue that we can still trust process. And that, in fact, has the way in which the news media has always built trust with the public is to say, we have a process, we follow this process, it's a rigorous process, we're transparent about our process. Therefore, you can trust that you're going to get the best or most faithful representation of reality that you can get. So if we can't trust the output of the media system, perhaps we can still trust a rigorous process. I think journalists need to double down on process and transparency of process and communicating that process well to the public. And really developing standardized and robust processes for verification of media that show the public that they're on top of this, that they're making a best effort at always looking at these various signals that might help them debunk or understand whether or not media has been manipulated. All right, so I'm going to stop there. I'm happy to take questions. And just to draw your attention to this, my book will be coming out next year. I get into some of these issues called Automating the News, How Algorithms Are Rewriting the Media. So it's not out yet, but put it on your future orders on Amazon. So thanks, and I look forward to taking your questions. I think we have about 10 minutes for questions. Have I depressed all of you? Yes.
Yes, Lars Nyre from the University of Bergen. So thanks for giving us, let's say, yet another presentation of how big these changes are, or how detailed and sort of scary these new technologies are. Yes. And it seems that all these presentations tell us that there's nothing really we can do to change these technologies. So that's maybe a question, but in my view, almost everything we are being told today suggests that technologies have some sort of autonomous growth, or giving us ever more opportunities and patterns and network movement possibilities, or whatever you want to call it. The thing is that this level seems to be completely under no control by any human. But what we can sort of try to control, or what we at least still have a sense that we control, is nearer to us. Like the content of next morning's newspapers in my local village, that's something we can sort of control, or the journalists can. So I'm curious, really, it's not a very precise question, but it seems honestly that we are in a situation where some things are utterly out of control, and that we should not really talk about it like that anymore. We should figure out, how do we work from this premise that we don't control these things?
Yeah, I mean, thanks for your question. I think that's an important direction. I think that technology has already been weaponized, and we can't control the malintent of other actors in the world. As you say, we can perhaps control our local media environment, but when the overall media environment is being polluted by anyone on Earth who has access to the internet and these technologies, there really is a lot, I think, that we can't control there, and so. Coming up with ways to cope with the world that we're kind of living in and the world that this technology is helping to create, I think that's the challenge for all of us. And I don't have any great new solutions. I mean, I suggest, well, we should double down on process transparency and use that to try to develop trust. And I do believe that could help us push back against perhaps some of the worst elements of this, but it's not going to make it go away. And I think we are going to need to think about how to regulate some of these things. We're going to need to think about, how do we authenticate people so we can have authentic online democracies where someone's voice is actually heard as an individual's voice and not as an individual's voice that's potentially amplified 1 million times because they're controlling a very powerful technology. So I wish I had a more upbeat message in this. I mean, I will also say that I think some of this technology can also be repurposed for very interesting, positive outcomes for the media. So imagine the storytelling possibilities that some of these technologies enable. You could, for instance, imagine new forms of alternate or augmented reality, for instance, which could allow you to convey information in new ways or more compelling ways, as long as it's kind of labeled as an illustration and you're being transparent, like this is how we created this presentation of information. So, I mean, I think it's, you could also look at some of this technology as an opportunity for media to learn how to deploy it in responsible ways. Yes, oh, we have a question back here and then up front.
My name is Knut Helland, and I'm working at the University of Bergen. It's very, very interesting, these themes coming up here, and what your presentation points to the fact that authenticity, which is such a core, both phenomenon and such a core concept, is also there are some problems related to artificial intelligence, and your argumentation is partly new for me, but also very scaring. And it is possible to connect that to the previous presentations. This is what happened. This is me. I mean that authenticity is not only related to what is happening, it's also related to us as individuals. And that is a kind of core value in our society. I'm an individual. I have individual rights, for example, human rights, the whole human rights thinking. So this, I mean, this is a reflection from my side that the future society might be very much changed in their basic values, or the basic values might have to be strengthened very much, or we need to have consciousness about these basic values in our future society.
Yeah, I mean, I think authenticity is really the key concept there, and I think the way you put it, we have a couple of options here. We can try to double down on our understanding, on our historic understanding of what authenticity is and what that means to us and how we represent ourselves, or perhaps we need to change and think about a new version of authenticity. I mean, I kind of think, yes, there is an authentic self, but whenever we're presenting ourselves in terms of individuals online, we're editing ourselves, right? So the version of me that you would see on Facebook or Twitter, is that my authentic self? I mean, I guess it's a version of my authentic self. But in any kind of edited representation or mediation of the self or of reality, you are going to be making some choices that may impact the authenticity. The question, I think, is how do you do that editing process and selection process while faithfully representing authenticity and not misrepresenting someone? So, and that for me again goes back to the process argument. It's like if we can show that we're following a process for editing reality or individual representation that maintains the sort of validity of that representation of authenticity, then perhaps that's a way forward at least. One more question, maybe?
Yes, Daniel Jung, digital culture at the university. Thank you very much for your talk. I have one request for comment. A few weeks or a few months ago, there was a popular app where you could upload your picture and see who's your doppelganger, your lookalike in art history, right?
Right.
A lot of people did that, but I noticed noticeable resistance amongst my friends and other parts of the population, Facebook population, saying, no, we are not going to feed this thing with our personal data. So my question is, will the aspect of resistance against this be in your book, and do you have a comment on that now?
I think the notion of resistance that I get into in the book is really a more formalized version of resistance. I talk a lot about algorithmic accountability and how to investigate these types of algorithmic systems, including machine learning systems like the one I'm showing you today. Of how to investigate those systems, uncover the biases in the data, how those algorithms may be influencing us or helping us to make decisions. So I kind of get into, I kind of see it as a formal investigation process through a variety of auditing techniques and crowdsourcing techniques that helps us understand how these systems are being used or perhaps disused or misused. But I think there is a whole other kind of reactivity which I don't get into, which is some people would call algorithmic disobedience. So what are the ways in which we as individuals can sort of withhold our data or obfuscate ourselves and which confound or confuse these types of systems as a form of boycott, as a form of reactivity against some of the consequences of these systems. So I think for algorithmic disobedience to really work, it's a collective action problem because I think you do need collective action to really hurt the algorithm at scale, right? Just one person withholding their data is not probably going to be very consequential. So there need to be ways for communities to organize around algorithmic disobedience so that we can collectively kind of, it's like collective bargaining. You need a lot of people at the table in order to bring that algorithm creator to sense that there's a counterpower that they have to cope with or deal with or modify the way they're working in order to account for that. So that would be my response there. Thank you.